Multiplication also has a lattice algorithm, which can be a bit confusing because if you say lattice algorithm, we now have to specifically say for addition or for multiplication. They both involve lattices, so we want to use the word lattice, but we don't want to confuse ourselves and use the addition algorithm for a multiplication problem. So the lattice multiplication problem works like this. You can take two numbers. They could be double digit, triple digit, single digit, whatever. You're going to create a rectangle where each of the numbers is written along the edge of the rectangle. Along the top edge here, we see the number 14 written out, and along the right edge, we see the number 23 written out. And then we create a grid where every place value for each number has a box. For example, the 1 in the tens place of 14 has a box. And that box is also used for the 2 from the tens place of 23. And then that box is slashed in half, very similar to how we drew the lattice for the addition algorithm. And the reason it's slashed in half, you probably guessed, is to separate the units and the groups. So as we go through this lattice algorithm, we're going to multiply number by number from each row and column, and we're going to write the number separating the digit that represents groups and the digit that represents units. So in this first box, I have 1 times 2. 1 times 2 is 3. That's 3 units and 0 groups. Let's move on to the next box. We have 4 times 2 here. 4 times 2 is 8. That's 8 units, 0 groups. Below this, I have 4 times 3. 4 times 3 is 12. That's one group of 10 and 2 units. So I need to separate the 1 and the 2 here. And then lastly, I have one more box to fill in. That's 1 times 3. That's 0 groups, 3 units. And now we're ready to add down our diagonals. Down our first diagonal, I just have the number 2, nothing to add to it. The next diagonal, I have 8, 9, 10, 11, 12. Now, I can't write 12 here because I'm only allowed to have one unit at a time, but since we've already mastered addition, I can keep the units digit 2 and carry the new group into the next diagonal. So now I have 1 plus 0 plus 3 plus 0, that's 4. And then my last diagonal is just zeros. To write my final answer, I'm just collecting all of these digits in order. I have 422, 422. Now the good thing about the lattice algorithm is that it's helping us to sort everything that we're multiplying. The bad thing to me about the lattice algorithm is that it feels very much like I'm following a recipe blindly, just like the standard algorithm. So let's see if we can compare the standard algorithm to this lattice algorithm. And to do that, we're going to repeat the process of filling in the lattice algorithm, but we're going to fill it in as we work through the standard algorithm. So if we do 23 times 14, my first step in the standard algorithm is 3 times 4. Now 3 times 4 would be this column, this row. In the lattice, we filled that in by writing one group of 10 and 2 singles. In our standard algorithm, all we're going to write is 2 in the units place and carry the 1. Now we're kind of carrying the 1 in the lattice algorithm. We're carrying it into the next diagonal, so there's a similarity there. Next we do 4 times 2, which is 8, and we're going to add 1 to that. So that becomes 9. In the lattice algorithm, we technically do the same thing. 4 times 2 is 8, that's 0 groups of 10, 8 here. And we are going to add the one that we just carried over. We haven't done it yet, but we will do it when we go down the diagonal. So it does make every step a little bit smaller, which might be easier to manage for younger kids. Going back to our standard algorithm, we need to put a placeholder 0 to represent that we're pivoting now in the tens place. We have 1 times 3. So now we're working in this row. 1 times 3 is just 3. And in the lattice algorithm, it looked like that as well. 1 times 3 was 0 groups of 10 and 3 units. And then we continue on in the standard algorithm, 1 times 2, which was 2. And that's the last box that we need to fill in our lattice algorithm. 0 groups of 10 and 2 units. The last step in the standard algorithm is to add the two products together. 2 plus 0 is 2. 9 plus 3 is 12. Carry the 1. 2 plus 1 is 3. Now we are going to do something similar in the lattice algorithm when we add down the diagonals, but notice that we're adding different numbers. But we get the same result at the end. So it's two different ways to represent the same product, and they're both, to me, pretty much just a process that we're following rather than an intuitive way of working through the problem. I think the most intuitive way to work through the problem would be using the base 10 blocks or any kind of manipulative, and then to use the partial products the way that we did in the last video.